That falls under this quality control steps. Now, it does not mean that only during construction the quality control steps needs to be maintained. If there is something that is there in the pre-construction stage which can actually affect the outcome of a project, then that also has got to be monitored. Quality of those work has got to be monitored. Is this? Now, in case of FDR, if I look at it, then broadly you can see that quality control can be divided into three stages. One is during DPR preparation, then before construction, then during construction. Now the question is, why these three different stages? Why is it different? How is it different? If you compare that FDR with some of the conventional approach that we follow, say for example BMDC roadwork, or even a CTB layer as a subgrade, or a base layer. Now these are all we are working with materials that we have a complete control on. As in, like, these are typical mixes, which has got very less variability. You'll be buying the material from a particular source, you have checked it all up. Then, even if it comes to the site, you can actually check it randomly and make sure that you are getting the exact same material that you have ordered for. Now, the source of aggregate, if it is not good, you can control that binder, the additive that you are using. That also you can control that depending upon what you need. You have perfect control of that. Now, the soil conditions that are existing when you are building up before the start of the roadwork, the subgrades is easily accessible. So anything that needs to be done on that, say for example, if you want to put some boro soil in it, you want to change the moisture content while you're compact, it's all possible. Now, if you look at FDR on the other hand, the mixed proportions can vary completely. It is not homogeneous. So because of that, 100% in stew material is what we are using. The existing whatever is there in the road, we are bound to use that. So all these different things, like some areas might be having brick bats, some would have a different aggregate sizes, some will have different aggregate source, soil type underneath can also vary. So all these things affect the quality of the product that you are getting. The layer configuration, the thickness of individual layers, that also can vary depending on the maintenance and rehabilitation practices that has been adopted on that given section. Then NMCs, the moisture content, natural moisture content of the soil can also vary. If you're working in an environment where right after rainfall event, then of course the in situ moisture content is going to be much higher when compared to what you have done as a testing process. So that also needs to be checked in, which is also a variability that is being brought into the construction. Then in certain cases, fresh materials may also need to be added upon so that the work can be completed. So this happening here. So if you look at the quality control steps, so if you look at the quality control steps, you can broadly divide that into three stages: DPR stage, before construction stage, and during construction. Again, we will discuss some of these things in the following slides. DPR stage involves identifying the depth of recycling that is required, the gradation that is coming out, then the plasticity of the soils, the in situ strength properties, development of your mixed designs, then the type of cement that needs to be used. All these things comes in as a part of the DBR stage preparation. And in terms of right before construction, the cement quality needs to be checked, additives checked, then water, the kind of quality of water that you are using, that also needs to be checked. Then comes in the third part, which is during construction. Now, the gradation that you are getting after pulverization, is it meeting the requirements that are set aside by the mixed design process? That is one thing. Moisture content, is it in concurrence with what has been asked for? Then the quantity of cement spread that is happening, is it according to what is being recommended? Uniformity of mixing, is it really achieved? All these things comes in as a part of your quality control test. Now, ultimately, you have to remember that it is all going to be done based on strength and durability properties. Now, the problem here is that why all these things that can be done in situ becomes, or at the time of construction, becomes very critical, is that the monitoring criteria, which is the compressive strength, can only be obtained after 7 days of curing, which means that the work has already completed. And now there is no, if the work is not done properly, then you are not going to meet the specific strength requirements, which means that all these tests that are being done are not going to be that I have mentioned earlier, pulverization, moisture content, quantity of trying good chance that the compressive strength, the strength requirements of that mix will actually be met. So that is the significance of doing all these construction checks in case of an FDR.
Sir, use the next button.
It's not working.
The bottom next button
It's
is
not
there.
working.
No, sir, there where you are.
Yeah, here. Oh, okay. Okay,
Yeah,
okay. I
last
got
one.
it. I got it. Thank
Yeah.
you. So in terms of DPR stage, depth of recycling. Now, recycling depth or thickness of the FDR that is required is going to be dependent on multiple factors, like design traffic is a criteria, then extent of distress that is there, which is contributing to the structural value of the payment, requirement of the payment, then the crust thickness that is there, subgrade types, all these has to be identified as a part of field investigation. Now, the requirements of in terms of the depth of recycling that can change if one of the things change. Let us say if the subgrade type change, then you may have to add a slightly higher or thicker section so that the structural requirements are met. So the sampling has got to be effective so that it captures all these differences and these can be accommodated as a part of your mixed design process. Now, sampling locations and frequency of sampling, that again becomes critical at this point. So next thing is subgrade investigation. Now, why is subgrade investigation essential in terms of quality, ensuring quality? Because this can actually seriously influence the fatigue life of your pavement section. Now, if you look at the typical test that is conducted, these are kind of like soil classification tests we do, then plasticity index testing, Satterberg limits, plasticity index, value testing is done. Then the in situ CBR properties of the subgrade soil is done, typically by using DRs in ASTMs. Now, one of the things that you can think of is that let us say you have a soil pavement that is existing, which has got say around 10 centimeters of boro soil that is present. And underlying soil is of really poor quality. That is why for a low volume road, a 10 centimeter or a 15 centimeter boro soil is actually kept. Now, when you are going 25 or 30 centimeters deep and essentially trying to mix everything up, you're actually utilizing that you need to account for that as well. So if the modulus is actually decreasing, then effectively what happens is that the the horizontal tensile strains on the bottom of your layer actually increases, and as a result of that, the service life of the pavement goes deteriorating once you have this kind of an issue in your section. Now, aggregate gradation for FDR. As you can see in the figure itself, if you look at the gradation requirements set for these larger size fractions, it's quite broad, starting from passing 95 to some of these sections. Say if I take 19 as an example, 19 mm sieve as an example, it can be anywhere from 45, passing 45% to passing 100%. Which means if I look at 475, it is also okay to have the stabilized pulverized layer to have 100% passing 4.75. That's also allowed in this particular specification that is given to for obvious reasons, which I'm not going to discuss much right now. So it's a very broad range. So now what is the problem here? Now, the moment you have such a broad range, anything that falls within that category is accepted. But depending on how much of that material, let us say if you decide as an engineer, you are deciding that, like, I'm not going to use 19 at all. So I'm going to go with 100. But instead, I will use 9.5. Now, it can go anywhere from 35% all the way to 100. So that is a requirement that is being set. Now, when you go from up to 35% is passing, the amount of fines which actually contributes to the strength of this mix changes accordingly. So which means that whatever is being decided in terms of what all kind of materials to be used has got to be accommodated as a part of something that is much higher than design. And you have to collect some samples from field and take it to the lab and then do your mix design. Now, how do you do it? I'm just giving you a simple example. There will be a couple of examples like this as in the following sections. Just 20 centimeters. Bituminous layer thickness is 20 centimeters. Width of the pavement is 3.75, and I'm proposing to widen it to 5.5. Now, FDR requirement, normally what we do is 5.5 if it is the carriage bay thickness, we give an extension of around 75 or 7.5 centimeters on both sides, which means that the total width of the base is going to be 5.65 meters. Thickness of the base that I'm planning to make is about 25 centimeters. Now, if you look at this figure right here, I'm just focusing only on the bituminous materials part in this example. The base and other layers I have not accounted for because it becomes more complicated. In a short presentation, it will be very difficult to for people to think through. So I'm just working on the bituminous material layer. And originally I had a layer which is about 20 centimeter thick, and I'm going to take the same quantity of material and I'm going to spread it across 5.65 meters. The given quantity of material now is spread across 5.65 meters. Now, what happens there? If compacted after this, then thickness of bituminous layer alone, how much is that going to be? Now, if I take 3.5 meter width thickness, which is of thickness 3.5 meter, 75 meter wide pavement section with a thickness of 0.75, and I divide it across 5.65 meters, then instead of 20 centimeters, I'll end up having a layer. Even if I take that layer and recompact it to 5.65, I'll end up having a layer which has a thickness of 13.3 meters, 13.3 centimeters, not 20. It's only going to be 13.3 centimeters. Hence, in sampling, if I do, that is what I'm going to do in my construction. Now, in my sampling, if I go ahead and use a vertical cut or a trench and I collect the entire depth of that bituminous layer in there and use it for my mix design, the quantity of bituminous layer in my mix design is going to be very different from what I end up having in the field when I'm constructing it. So because of that, when you are sampling for gradation analysis or for mix design, the thickness of HMA that needs to be selected should not be 20 centimeters, but instead should only be 13.3 centimeters. Now, the subgrade soil thickness in that case, considering that the total FDR thickness is 0.25, the subgrade that needs to go, or the base and the remaining materials underneath, the thickness of that needs to be collected comes out to be 11.7 centimeters. Now, significance of mix design. Why is everybody saying that mix design is something that is very critical? You have to account for that. So the simple reason is that we are not constructing a flexible layer. We are not constructing a rigid layer. This is something that is in between, a semi-rigid kind of layer, which means you end up having to be in a certain bracket window in terms of your strength and durability requirements. So that is where the challenge is. If you add more cement, the strength will go up. And as a result of that, you end up having a material which is of very high strength. And as a result, there might be other problems like shrinkage and crackings and all those things that happen. Now, if the cement content is different or the strength is very low, then you may essentially having a very section that has got a poor load carrying capacity. So the technique of a mixed design is actually to maintain certain level of strength, but not too high or not too low. That is where the challenge comes in, considering that there are materials that are going into this particular work has got a lot of variability in there, like what I have mentioned earlier, the big bars, the size differences, all those things. So that is what makes the mixed design a challenging task, and that is why we have to find that optimum cement content for that particular mix which we are going to be using in that field, which means the mix cannot change and the cement content cannot change. Or if you are an additive that you are adding, like a chemical additive that you are adding along with cement, that also cannot change. So that is the challenge that you have in terms of mixed design. Now, how to do that? Sampling, again, typical practice is that you take one sample out of every kilometer. That is a typical practice. Now, we prefer to have open trenches, excavation, and then you collect your samples out of that. That brings in more homogeneity in terms of the samples that you are collecting. You can choose multiple options, as they can be depending on the road that you actually see. If it is damaged along the outer wheel path, then it's good to have a sample collected there and something outside of that as well, so that the uniformity is maintained as you go along in terms of your sampling. Now, along with making trench pits for collecting samples, it is always a good practice. It's always a good practice to have multiple trenches. Even though you don't use it for sample collection, you dig multiple trenches and make sure that the sections that you have collected upfront, a priori, where you have sampled your materials, the consistency of the sections remain the same as we go along. So just cut it open and measure the thicknesses and make sure that there is no change. with respect to the one that you have collected your sample. Now, the other thing is that it's related to the information on maintenance history and construction history, which is something, as we all know, is very difficult for any agency to maintain, and practically you will not get much out of it. So the only option that you are remaining with is to try and do your own exploration in terms of like trial pits and everything, and collect your own samples and make sure that you are getting a representative one when you are doing your mix design. In terms of sampling, few things to remember: visual observation, that is very key. Distress identification. Drainage issues is a very easy thing that can be visually identified. Uniformity of the section can also be done by using multiple pits. Now, you can determine a representative section and how many mix designs you may have to make, considering the variability in terms of the sectional thicknesses across the length of the road. Very difficult to identify a representative section, but still it is possible in case of some part of it is possible during, especially drainage issues can be easily addressed by the visual inspections. Now, trial pits, representative sample is what is being done. If milling and removal is required, then additional materials is required.